Mars wasn't always a thin, cold, mostly airless desert. Billions of years ago, it had a thicker atmosphere, and the Sun has been quietly taking it apart ever since. Orbiting spacecraft have photographed dried river channels, ancient lake beds, and mineral deposits on Mars, including clays and carbonates, that on Earth only form in the presence of liquid water over long stretches of time. For that water to have flowed across the surface in the first place, Mars needed a thicker atmosphere, one dense enough to trap heat and raise surface pressure enough to keep water liquid, instead of it instantly freezing or boiling away into the current thin air. Some of these features, like massive outflow channels carved by ancient floods, suggest the water didn't just sit quietly on the surface but moved in dramatic, large-scale events. The trouble started when Mars lost its global magnetic field, likely within its first billion years of existence. Earth's magnetic field, generated by the churning of our molten iron core, deflects most of the charged particles streaming from the Sun around the planet. Mars is smaller than Earth, so its core cooled and its internal dynamo shut down far earlier, leaving the planet's atmosphere directly exposed to the solar wind, with no global magnetic shield left to redirect that constant stream of particles. In 2014, NASA's MAVEN spacecraft arrived at Mars specifically to measure this process happening in real time. Its instruments confirmed that solar wind particles strike the upper atmosphere directly and strip away gas particle by particle, a process that accelerates dramatically during solar storms, when the Sun's outbursts hit Mars with much greater force. MAVEN measured Mars losing roughly 100 grams of atmosphere every second under normal conditions, a slow, steady leak that adds up to enormous cumulative losses across billions of years. Mission scientists also found that Mars loses atmosphere in sharp bursts tied to specific solar events, including coronal mass ejections that measurably strip away extra gas within just a few hours. The result is the Mars we see now, an atmosphere less than 1% as thick as Earth's at the surface, too thin to support liquid water or block harmful radiation reaching the ground. It's a preserved, ongoing example of what can happen to a rocky planet's atmosphere once its magnetic shield disappears, and studying it gives scientists a working model for judging atmospheric habitability on rocky worlds elsewhere, not just here in our own solar system. Comparing Mars to Venus, which kept a thick atmosphere despite having no global magnetic field of its own, has also helped researchers understand that atmospheric loss depends on more than magnetism alone. Subscribe for more stories written in a planet's missing atmosphere.